In tonight's omarvision tutorial, I'm going to go and do the next step in this procedural mesh thing on our way to making like a terrain with a procedural mesh. And, you know, we got the triangle, then the quad, then the cube, and then a bunch of cubes, and we're calling that a chunk. But when we drew the chunk, you know, we kind of like tried to make more and more and more. We made like a chunk that had 1 million cubes in it, and it took like 4.3 seconds. So let's see if we can optimize that. So I'm going to start off kind of like from this Unity package here, if you wanted to download this and do the project along with me. All right, so what do we have is that project that we had when we made a chunk. And right here, I did a couple of changes here to the chunk from last time. Like I made the size of each cube just a little bit smaller so we could see that inside our cube, whatever size it was actually drawing all the sides of every cube within the chunk. All the sides, even if you can't see them when the cubes are full size, like a size of 1. So I figure the first optimization we could do is to not have to draw the inside sides of a chunk of cubes. So that's what we're going to do in this video. We're going to decide how do we know when there's a side that we have to draw or not. So let's go ahead. I added I added this third floor here with the blue dot. And on that blue dot there, I'm going to start to have another chunk draw. And on this one, I'm going to try to optimize it. So let's create another script for an optimized chunk mesh. So I'll create a new script, chunk mesh optimized. Optimized. Yeah, optimize. That's a good name. Boom. And what the heck? Then let's put it on that empty game object. That's a blue dot. Let's put that on there. Chunk mesh optimize and just drag it on there on that blue dot. Ooh, okay. Good. Now the script at first, let me always do my cut out, and start from the same place. So we know that this script is gonna be very similar to the chunk mesh script. It's just that we're gonna change a couple of things so that we don't have all those vertices, all those sides that we're gonna have the Unity try to render. So the chunk mesh script is something we can copy from. I modified the chunk mesh script a little bit, just a little bit, from the last video. But let's see. Yeah, let's copy our little helpful reminder about this, the vertices in a cube. I like that. Then let's see what else. I had a little helper section here where I kind of enumerated all my quads for the sides of the cube. And then I had another array where I just had the points, these points here like A, B, C, D, E, F, G, H. I just declared them as vector offsets from like an offset of this being 0. And that's what this is. Except I changed this one a little bit so we could see the cubes be a little less than 100%. So I made a percent variable and see I made it 0.9%. So here if I took this and made it 5, you're going to see that the cubes in the Unity, when they're built on our chunk mesh over here, the first one, they're going to be half the size. Like that. See? Half the size. And yep, I added that percent in there just so you guys could see that it was drawing all the sides of the inside cubes. All right? But of course, if we put that thing up to 1, you know, like 100% there, then the cubes, you won't even notice that if those inside sides were drawn or not, like if I did right now. So you don't even notice if the inside ones are there or not, so why am I drawing them? Okay. So we need that. So let's copy this into our optimized script. Copy, and let's paste that in here because we're going to still use these things. And what about the variables? We're going to need the offset and the percent variable and the material variable, and we're getting how many, how big the user wants the chunk to be, so we're going to take those, and we're going to use them here too. Okay, except this now, I'm going to change the name to chunk size. It's a little bit more descriptive, I think, of what we really want to do. That's really specifying how big the chunk is in cubes. So now if I look over here, you see that says chunk size, and I could say something like, let's start off with 2, 1, 1, just to see, and let's drag that bare material on here again. Okay, now let's see, what else do we have to do? Well, now we have to think, because in this one here, we had the vertices, the triangles, the UV. These are the arrays that are the mesh data. In the start function, you know, we allocated our arrays to be big enough to hold a size of the chunk worth of vertices. Then we define the mesh. You know, we just went through for each cube in the chunk, and we use that as an offset. Then we got the mesh and set the mesh. Now, I was thinking, for us to know whether we're going to draw a side of a cube, we have to know if that cube has a neighbor next to it. Okay, so let me just look at this picture again here. Oops, let me turn the percentages back down so we could see something here. I just want to show it in the chunk mesh script here. Let's put the percent sizes back down again to, I don't know, 0.6. Okay, 0.6. Save it so I could explain something here with this visual representation of this 3x3 chunk. See, somehow when you're looking at the chunk that's there, right, it's these outside faces, they don't have a cube adjacent to that face. This face that's over here doesn't have a cube adjacent to its face. So that cube we want to draw. These cubes on the top, there's no cube above them, so that face we want to draw. But the ones inside here, like these two faces on the inside, this face we are not going to draw because we'll do a test. We'll say, okay, is there a cube beside me? Is that cube on? Is that cube, you know, going to render? And then if that cube is beside me, I will not draw this face. And then when we get through and we're drawing this cube up, we're defining the data for this cube, we'll do the same thing. We'll say that on this face over here on the left, is there a cube next to me? And we'll say, you know, is there a cube next to me on the on this side? And if there is, then we won't draw the face. That's what we want to do. So basically, we're going to have information about, somehow we're going to have to store like whether there's an on or off for each of the cubes. So I'm going to like do another helper object up here and helper stuff here, and I'm going to make another helper class, and I'm going to call it like a chunk object. Okay, just to keep things organized for myself, I'm making this class called chunk object. And here, the chunk object, oops, am I in the right script? I am not in the right script. Sorry, hold on. Let me cut that. I'm in the chunk mesh script. Let's just put them side by side so I could see them side by side. All right. New vertical group. Okay, so on this side is the chunk mesh, the unoptimized where it draws every side, and on this side I'm trying to create something new that I don't draw the inside faces. So yeah, first thing I said, I want to make a class, and the helper's here, another subclass, class chunk object, and in this chunk object, I could probably take the chunk size variable and put it in the chunk object, since that's something, that's information about the chunk object, really. Should I? Well, first off, let's do this. We're going to need an array. We're going to need an array of all the cubes, and I'm going to make it a three-dimensional array. So public bool is going to be a Boolean array, and it's going to have 3 dimensions, x, y, and z, you know, so it's a three-dimensional array, and it's going to be a bunch of cube objects that are going to be stored in here. All right, and what I'm going to say for each cube is that cube on or off? So if the bool at that x, y, z position in the array equals true, then that cube is going to be rendered, and you know, and if it's false, then that cube is not going to be rendered. So that's first thing. I have a bool to store which cubes are on or off in my chunk. And instead of having these things here, I'm going to throw them into the chunk on my optimized one, just organizing things that, you know, this has to do with the chunk. And then when somebody specifies the size of the chunk, I want to store the size, all right? Because I'm going to be going through loops, so I might also store the size. So private int size x, and I like initializing all my variables. Private int size y, and private int size z. Size z, okay, equals 0. Let's do that. Now, think. Now, what do I want? Okay, so I still have this chunk size here. Now I'm gonna have to have the chunk object, but that's private. The class, only inside the class do I need to know about that. Don't need to show that to the user. The chunk object, we'll just call it chunk object. And then at first that's gonna equal null, yeah. Okay. And then in the start, private void start, spell that right. We'll allocate the chunk object, and we'll tell it how big it's going to be. So let me make a constructor here, public chunk object, and have it take an int for the x, int for the y, and an int for the z. That'll be like the sizes. And so the first thing we're going to do, we have to allocate the chunk object. So chunk object, oops, lowercase, chunk object is going to equal a new chunk object, and we will take the chunk size that the user told us. Chunk size x comma int chunk size dot y comma int chunk size dot z. Boom. Let me just see. That looks like. All right, so then here in the chunk thing, now we'll allocate the arrays of our chunk object. Right. We will allocate the arrays. So the vertices array is going to equal a new vector 3. Well, I guess we have to know the size of the arrays just like we did before. So that int array size is basically going to equal x times y times z. That's how many cubes we have. And then we have to multiply by 36 because for each cube, we have 36 vertices. And now for the vertices array is going to equal a new vector 3 array size. And the triangles equals a new int array size. I got to do it like this, sorry. Not the parentheses, but the straight brackets for an array. So I could use like a list or a dictionary and stuff like that, but those aren't as fast as straight arrays. So I'm using, straight arrays. And then the UVs, don't forget them, equal a new vector 2 array size. Okay, so that'll allocate our arrays, will hold our data. Why did it turn into a 3? I said 2. Did I type 2 or 3? Anyway, it's a 2. And what else should we do? Then right here, there's a cube object, so we can say which ones on or off. See right here, it's null. But now that we know how many cubes we're going to have, we could allocate that too. So cube objects in the constructor equals new bool x comma y comma z. Okay, and then I guess we want to initialize all those cube values. So I'll just make a function to call that init cubes, because right now I'm going to turn all the cubes on, but I may want to play around later and start turning cubes on and off. So I'll make a function for that where I set each of the cube objects equal to on. And that will look like this. Boom. Okay, so I loop through ZYX and I set all the cube objects to true. And then over here, I did store the size that was given in XYZ. That could probably be useful information. So I will say size X equals X and size Y equals Y and size Z equals Z. Probably is going to be useful to me later on in my coding, so I'm going to store those. Don't want to forget them. Okay, so that takes care of here allocating to hold my data. Now I want to start being able to define the data. And since the chunk now, this chunk object is the thing that's going to do all the calculations for the chunk, it has the information of which cube is on or off. I'll probably want to make a function here inside of this. So let's say chunk object dot define mesh data. Okay, but now we're going to give it to this chunk object class. And then we're probably also going to want to have, we still want the script here to get the mesh. So let's make a variable here for the mesh. Private mesh equals null. And let's get the mesh. So mesh will still equal get mesh. And this function has been the same since we were making a triangle. So I could probably just use it over again. So let's see, where's the get mesh function here? And it returns a mesh, so that's great. I could use that. Copy. And paste. Boom. So get mesh will get a mesh. And then since the chunk object has all the data for the mesh, then we could call chunk object dot set mesh. And we could pass it in the mesh object, but probably to make it faster, let's pass it in a reference. So when we call this function, it doesn't have to make a copy of the object, but it just passes a pointer to this object. It works a little bit faster. So now in ChunkObject, we have to make a DefineMesh function and a setMesh function. So here, let me just chunk up some of this stuff here. This was the initialization. We have to make some more functions here. We definitely have to have a public void DefineMeshData function. Okay, so that will satisfy this, DefineMeshData. And then we'll have to have a setMesh one. So public void setMesh. And this one is going to take a reference to a mesh object, and we'll just call it M. But then inside the internals of setMesh, it's still going to be the same. So I probably could just use this still. Just like we did for all our other ones, copy. We're just moving it into here. Since this has the arrays, vertices, triangles, and UV. All right, so now let's start writing the DefineMesh function. Think, Omar, think. When I write the DefineMesh function, let's see, what do we have when we did the cube? Let's start from there. So here's the DefineMesh from when we did a cube. So let me just copy that first and put that in here. All right, so this is all about the chunk, all the triple loop here, that's about the chunk. And here, this is where my size X, Y, and Z could come in handy. So I could say size Z, size Y, and size X, a triple loop, so I can get all 3 dimensions for the cubes that go in all 3 directions. And then the offset values, they will still follow the same formula for the offset into the vertices array, except here, just change my name to size X, size Y, and Z. X and size Y. Okay. And then the position, that could equal X, Y, Z. And now we're going to go through all the sides. This is where we got to get different. So I think I could close this now, because now this is the part we have to think about. This just says draw the quad, you know, for all sides. But now we want to think about, based on which quad, we got to see if there's a neighbor. So let's make a switch statement for the code. All right, but instead of calling it code, I'm deciding to rename this to quad, so I could read this easier. And now I want to make a case statement for whichever quad it is, because I'll have to check for a neighbor on a side based on that. So let me see, what's my case for enum quad dot back break case enum quad dot front break, and I'm going to do this for all the 6 sides. Front, top, enum quad dot top break case enum quad dot, oops, I just noticed case, bam, there's enum quad, tab, dot, top, bottom, break, case enum quad dot left and right, left, break, and then right, case enum quad dot right, and break. All right, so that's all the sides. So if we're drawing the back side of a quad, that's the side that's facing, you know, me. Like, you know, if I'm the camera looking at the cube, the back side is facing me. So I have to see if there's a cube beyond that. Let me just make a little variable here, bool on, okay? And yeah, I always like initializing my stuff, equals false. And then so over here, I will see on to see if this cube is, to see if I'm going to actually draw this side or not. Let's see. So I should call it show, really. Show. Whether I'm going to show this quad or not. It's going to be, I'm going to have to look in that cube objects array at position X, Y, Z. And actually it's Z minus 1. Okay. And all right, so this is a shorthand notation. Well, I'm not equal Z minus 1, right? But I can't look for a cube behind me if I'm already at the last cube, so I better check for Z greater than 0. Okay, if Z is greater than 0, then there's a cube behind me, you know, and I could use the value from my cube objects of the cube behind me. Otherwise, just show that quad. There, how's that look? All right, and then I'll have to modify something here. The DefineQuad function will take which quad, will take my vertice offset and my position offset for the cube, and whether I'm going to show or not. Boom. All right, so we're going to need a DefineQuad function, which I don't have here. So I guess I got rid of that cube mesh thing a little too fast. Let me get it again. Cube mesh, chunk mesh, chunk mesh. This is the non-optimized one. And let's copy this DefineQuad function. Copy. And yeah, we're gonna have to put it in our chunk object class. Let's put that in here. Boom. All right, because this defines the quads for the cube. All right, and it's just gonna take one more parameter to show. It's a boolean. So comma bool show. Okay. Boom, boom, boom. And we'll have to modify DefineQuad to take into account show. Just not yet. First, let's finish this logic. All right, so this checks the cube behind. See, z minus 1. And it uses if it's on or off. Otherwise, if we're at the last cube there, it's true always. Now let's do the same thing with front. Show equals, so with the front, the thing we have to make sure is that we're not past that z is less than our maximum cube z index. And arrays start from 0, not from 1. So that would be size z minus 1. Okay. So if we have a cube that could be in front of us, then we'll use the cube objects. We'll check in that array, and this will be x, y, z plus 1. And we'll use that boolean that was set or not set. Otherwise, we'll just always have it on. And then we have to call define quad. Quad v comma p comma show. Right? So now it's going to do the same thing for all the rest of these. Show equals y has, this is the top, so something y has to be less than size y minus 1. Cube objects x comma y comma z. So y minus 1 because I'm going to add 1 plus 1. Okay. Yeah, or just always equal true if there's no array index there. Define quad. Quad comma v comma p comma show. Then bottom. Copy bottom. It's going to be opposite is have to be greater than 0. And subtract 1. And then left and right. So left and right is the x-axis. So left, if I'm on left, I'm going to have to be greater than the leftmost, greater than 0. And that would be a minus x, oops, that's x minus 1. And then to the right, copy, to the right, that's going to be x less than size x minus 1. And this is a plus 1. Okay, so yeah, that looks right. Whether I'm going to show that side or not depends on if there's a cube that's on that side or not. Cube objects. That's just a three-dimensional array to say if the cube's on or not. So that should work. Let me just see if this builds. Build solution. Build succeeded. Okay. Whew. All right, so we're passing whether we're going to show it or not. Right now, define quad. Here, let me outline my code. Okay, right now, define quad. It always defines points, you know, in the cube. It's always using that. It's always doing that. But right now, we have to do a thing where if it's not going to show, that we don't give it points in the scene, so that nothing will draw. So what we're going to have to do here is we're going to have to put an if here. If show equals true, then we could do one thing, else we will do another thing. So if show equals true, then we will render this quad just like we always were. Else, we will not set any point values. So to do that, we could just say vector3 dot 0. Okay. and there'll be nothing to render. Vector 3.0 for all of them. Vector 3.0. And we'll keep doing that. Okay, so we'll do that with back, and we'll do that with the front. Okay, so we modify the front, and we'll do the same thing for top. There we go. And let's do it for the bottom. And we're almost there, just left and right to go. That's the left. And now for the right. There. And that should finish up changing our DefineQuad function to show or not show. Okay, so let's take a look here. What do we got? Got a lot of changes. So the main thing I have to remember is that we were trying to make changes for showing and not showing. Let me just do a build here. See if there's any errors. Okay, that's exceeded. I think it's time to cross my fingers. Now let's go into Unity and let's make sure we have a chunk here. First, let's start with a 1, 1, 1 and see if we render this 1 cube properly. Okay, that looks good. We got 1 cube. And what's my percent size here? It's a 1. Let's make it down a little bit so we can tell if it's rendering extra sides or not. And now let's try 2 cubes and X. Play. And there we go. We got 2. Now I don't see a side. Let's go to scene view. Right, so you see where these sides match up. I do not see the sides being drawn. That's what I wanted. Good. But I should see a side here, correct, and a side here. And underneath, I should also see that there are sides. There are. And then finally in the back, good. So only where there's cubes being neighbors should those sides not be drawn. So far, so good. Now let me just try 3, 3, 3. 3, 3, 3, because that should test all our conditions of how cubes could touch each other in a chunk. And it renders out, and it looks true. I don't see anything in there that's being rendered. They're, yep, on the back side, they're not being rendered. It's just the outside sides that are being rendered. So this is working. So this one is going to have just that many less faces to draw than this one does. You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects, and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.